Hello there, and welcome on the LabHub. So today we're gonna talk about a really interesting topic that many people don't really understand, and even college students don't understand. At PhDs, sometimes this is electromagnetic waves, and this is one of the most complicated topics uh, in a physics. Yeah, it's not so complicated as maybe quantum physics or some theories, but for college students on their first years and for high school students, it's a really confusing one. So this is electromagnetic waves. And according to its definition and basically according to its name, electromagnetic wave, it's a magnetic wave plus electric wave, right? And we already had a lesson on magnetism, and we know the magnet is the north and south poles, and the magnet induces a magnetic pole, right? So this is a magnetic pole. That's all you need to know about magnetism in that case. But what about electric wave? We didn't actually talk about it. It's better to show on a graph. So, as any wave, it has its wavelength, it has its amplitude, right? And it has its frequency. So basically, electric wave is just a length. It's just a wave with its properties, right? But since any length in our world has its limits, basically the sound wave or the wave induced by drip falling in the ocean, the electric wave is a limit because its speed equals the speed of the light, which is 3 times 10 in the 8th power meters per second. And this is the speed limit of the universe. And with this amount, we'll work in a general relativity and special relativity by Albert Einstein in advanced block. But now, just memorize it and just know that this is the most possible speed can be reached, and humans cannot really reach it. So, or also a weird sign times frequency. What is the weird sign? This is the wavelength, like a half-life. And lower wavelength leads to higher frequency, right? So, frequency, as we know, is 1 divided by t, which is period. Maybe we can know something else about electromagnetic waves. And yes, we can. We can find their energy. The energy of electric wave equals to the Planck constant times frequency. The Planck constant is more a quantum physics, but we actually need it to find the energy of electric wave. So Planck constant equals to 6.626 times 10 in the negative 34 joules times second. And it's basically all we need to know about electric waves. But what is actually electromagnetic waves? An electromagnetic wave, we need 3 dimensions to represent it. At first, right? So this is time. Okay, let it be time. And this is E, which is electric field or electric wave. Basically, every field induces its waves, such as electric wave, or magnetic field induces magnetic waves. So this is electric field, and it induces some wave. Okay, but what about this thing? What is this? This is a magnetic field, which is B. And the magnetic field is in this scale. Right? It's another dimension, but it's really close to electric wave. And this is the structure of the electromagnetic wave. This is both electric and magnetic wave. An electric field equals to speed of light times the magnetic field. Here's few things you need to know, few science definitions you need to know in further. So I recommend you to just save it. E is electric field, B is magnetic field. What is H? H, it is magnetic field intensity. D is a current density, basically I per area. And one important note, this is what we're driving right now. This is for electromagnetic waves and basically for Maxwell's equations. This is a college level, and if you are a college student, you really need this, because in your electromagnetic waves course, it's a really tough one at first, and this is basics of electromagnetics, and especially of Maxwell's equations, which is like a Bible of electromagnetic field and electromagnetic waves. So D is current density. A big D is electric displacement. Field. And P is free charge. This is all you need for Maxwell's equations. We won't really use it right now, but we will use it in further on Maxwell's equations course. And if you are studying currently only electromagnetic waves, I suggest you to save these definitions because they're really useful. Let's go back to electromagnetic waves itself. How can it be induced? Basically, it will be induced by electromagnetic field. So in simple words, right? Coming back to the magnetism video, to the magnetism guide, we got some magnet. And we got some loop. And in this loop, there is electricity right here. And it has its electric field. And a really important note, this field is active. So the electrons isn't move. They're moving right now. So basically, if you like put your finger near this thing, near enough, right, in the area of this field, you will feel it. You will feel the electricity. So when we put the magnet near this stuff, near enough, right, the waves by electric field combines with the waves by magnetic field. And we can state that active electric field near the active magnetic field leads to formation of the electromagnetic field, which causes electromagnetic wave. This is a really super simple explanation, but this is actually how it works. And the opposite thing, if we put active electric field in active magnetic field, we're getting the same result. And for now, this is all you need to know about this stuff. This is an introductional video, and it's not so complicated right now. Now you know what is electromagnetic waves and what is electromagnetic field basically, and how it can be induced. But in the future, there will be super complicated videos on this topic, because this topic is really complicated, one of the most complicated, on my honest opinion. So good luck. Thanks for watching this video, and see you on the next lesson.